Hello everyone and welcome to another Solve With Me video. Today we will be discussing about waves. So let's go to the first question. What is the wavelength of a 5 Hz wave that travels with the speed of 10 meters per second? So first of all, we have to know this formula, wavelength times frequency equals to velocity. This is a really important formula. And then we write this equation in this form. Alright, which in this case the velocity is, the speed is 10 and the frequency is 5. This means 2 meters. So the answer is D, 2 meters. A rope of length 5 meters is stretched to a tension of 80 newtons. If its mass is 1 kilogram, at what speed would the 10 Hz transverse wave travel down the string? So the speed of a transverse traveling wave on a stretched rope is given by this equation. I'll write it just here. So we write this equation so we can get the speed, right? And then we calculate our speed, which is 1 times 5 here, which is under root 400, which is 20 meters per second. Perfect. Now let's go to the next question. A transverse wave on a long horizontal rope with a wavelength of 8 meters travels at 2, so wavelength equals to 8 meters, travels 2 meters per second at t0, t equals to 0. A particular point of the rope has a vertical displacement of plus a, where a is the amplitude of the wave. At what time will the vertical displacement of the same point of the rope be minus 10? So the time interval from a point moving from its maximum displacement above y equals to 0, which is equilibrium, to its maximum displacement below equilibrium is equal to 1/2 of the period of the wave. So in this case, we have t equals to 1 over f equals to wavelength upon v. In this case is 8 upon 2, which is 4 seconds. So the desired time is wavelength upon 2. This is 2 seconds. So t equals to 2 seconds. What is the wavelength of a wave with period 2 seconds and speed 2 centimeters per second? So first we have to notice that here we have centimeters, also in the questions, both in the questions and in the answer choices. So we don't have to change anything about that. So from these equations, I will write just here, and frequency, of course, we know it's 1 over the period. We know that we can get that the wavelength equals to velocity times the period, which in this case we have 2 centimeters per second times 2 seconds equal to 4 centimeters, which is E option. Now let's go to the next one. A string fixed at both ends supports a standing wave with a total of 4 nodes. If the length of the string is 6 meters, what is the wavelength of the wave? So first of all, we know that the distance between successive nodes is always equal to 1/2 times wavelength, okay? If a standing wave on a string fixed at both ends has a total of 4 nodes, the string must have a length L equals to 3 times 1/2 length. So if the length equals to 6, then that would be 3/2 wavelength. Then the wavelength will be equal to, yes, 4 meters. So the correct choice is E, 4 meters. Now let's go to the next question. A string fixed at both ends has a length of 6 meters and supports a standing wave with a total of 4 nodes. We have already did this, I think. Wait, is this the same? Oh, no. If a transverse wave can travel at 40 meters per second down the rope, what is the frequency of the standing wave? So we have already found in the previous question that wavelength equals to 4 meters. Since the velocity is 40 meters per second, the frequency of the standing wave must be, let's write the equation, v upon wavelength, which is 40 upon 4, which is 10 Hertz. This is B option. Now let's go to the next question. A sound wave travels through a metal rod with a wavelength and frequency. Which of the following best describes the wave when it passes into the surrounding air? Wave rule number 2 states that when a wave travels from one medium into another medium, the frequency remains the same. So this already eliminates option B, D, and E. We have to use this elimination rule, okay? When the wave enters the air from the metal rod, its speed will decrease. The frequency, however, will not change. Since V equal to wavelength time frequency must always be satisfied, a decrease in V implies a decrease in wavelength. So if this decrease, because they are directly proportional. So the correct answer is A, less than wavelength equal to frequency, okay? Now let's go to the next question. In the figure below, two speakers S1 and S2 emit sound waves of wavelength 2m in phase with each other. Okay, now let's take a look at this diagram. Let AP be the amplitude of the resulting wave at point P and AQ the amplitude of the resultant wave at point Q. How does AP compare to AQ? Really nice question. Now, the distance from S2 to P, we know that is 5 meters. It's the hypotenuse of a 3, 4, 5 triangle. And the distance from S1 to P, it's exactly 4 meters. The difference between the path lengths to point P is 1 meter, which is half the wavelength. Therefore, the sound waves are always exactly out of phase when they reach point P from the two speakers, causing destructive interference there. By contrast, since point Q is equidistant from... Where is point Q? You see it here. Point Q is equidistant from the two speakers. The sound waves will always arrive in phase at Q, interfering constructively. Okay? Since there is a destructive interference at P, here is a destructive interference at P, and a constructive interference at Q, the amplitude at P will be less than Q. Everything makes sense. So the amplitude at P will be less than, because here it's destructive interference, and here is constructive. Hope you got this. An observer is 2 meters from a source of sound waves. By how much will the sound levels decrease if the observer moves to a distance of 20 meters? Alright, so the intensity, power per unit area, is proportional to 1 over r squared, or 1 over the area. Okay, so we know that the intensity is proportional to 1 over r squared, where r is the distance between the source and the detector. If r increases by a factor of 10, let's put this one here, okay, then the intensity decreases by a factor of 100, okay? Right. Because the decibel scale is logarithmic, if the intensity decreases by a factor of 100, which is 10 power 2, the decibel level increases by 10 plus 10, which is 20 decibels. Okay. Now, an organ pipe that's closed at one end has a length of 17 centimeters. If the speed of sound through the air inside is 340 meters per second, what is the pipe's fundamental frequency? So we know that an air column, such as an organ pipe, with one closed end resonates at frequencies given by the equation. Here we write this equation. Okay. For odd integers n. The fundamental frequency corresponds by definition to n equals to 1. Alright. Therefore, F1 equals to V upon 4L, which is 340 upon 4 times 0.17, which is exactly 500 Hertz. So it's B option. Now let's go to the next question. A bat emits this 40 kilohertz chirp with a wavelength of 8.75 millimeters toward the tree and receives an echo 0.4 seconds later. How far is the bat from the tree? Really nice question. So the speed of the chirp is V equals to wavelength time frequency, which in this case is this, right? and we will calculate that using a calculator or without, which is 350 meters per second. If the distance from the bat to the tree is d, then the wave travels a total distance of d plus d, which is 2d. Round trip distance, if d is the time for this round trip, then we'll have this equation here. This means that the distance is this. So we'll have to calculate these calculations, and the answer will be 70 meters, which is B option. Now let's go to the last question. A car is traveling at 20 meters per second away from the stationary observer. If the car's horn emits a frequency of 600 hertz, what frequency will the observer hear? Use this. Okay. So since the car is traveling away from the stationary detector, the observed frequency will be lower than the source frequency. This eliminates B and C. Using the Doppler effect equation, we can find that. I'll write here equation, and we'll just use this equation in our question. So this will further be equal to this. It's quite an easy equation to solve. This is a total of 34 upon 35 times 600 hertz. So the answer here is A. This was was a longer video. I really hope it was helpful.